This is going to be a quick little video about simplifying radical expressions. So we're going to take all these radical expressions and we're going to simplify them. What do we mean by simplifying them? Well, we want to remove as much as we can from under the radical. So, take a look at that first one, the square root of 9. The square root of 9 is 3, right? So we're done. That is simplified. 9 is a perfect square, so when I take its square root, I get 3. Period. No more radical. We have done the ultimate simplification. We have gotten rid of the radical altogether. In the big scheme of life, there aren't that many numbers that we can do that with, just the perfect squares. So what do we do with something like the square root of 18? Well, are there any perfect squares in 18? Can we break 18 down? There are a couple of different ways to do this. My preferred method, the method that works for most of my students, I'm going to go ahead and break 18 down into its prime factors. Now you've done this before. The number 18 breaks down into, let's say 6 and 3. 6 further breaks down into 2 times 3. So the prime factors of 18 are 2 times 3 times 3. 2 times 3 times 3. The ends of the branches, the ends of these little branches here, so 2 and 3, are the prime factors. Now we're taking the square root of that. Remember, it was the square root of 18. We're taking the square root of that. Anything that you have 2 of, like a 3 and a 3, when you're taking the square root of that, anything you have 2 out, you can take the square root, or anything you have 2 of, you can take the square root of that. This is really 9. 3 times 3 is 9, and the square root of 9 is 3. So I can pull a 3 out of this radical just like I did up here. But there's still a 2 left over. That 2 is all by himself, and the square root of 2 can't be reduced. The square root of 9 can be reduced, but not the square root of 2. So the 3 comes out, the 2 stays in. The 3 comes out because there are 2 of them. They make a square. They're squared. There's 2 of them. They can come out. The 2 has to stay inside because he's all alone. Let's try this one. When you think about 50, I don't know what you think of. You might think of 5 times 10. 5 doesn't break down anymore, but 10 does into 2 times 5. So now your prime factors are 5 times 2 times 5. 5, 2, 5. Now remember, you're taking the square root of that. Your job is to take anything out that you can. But you can only take things out if they're pairs. So look, you got a couple of 5s. So you're going to take that 5 out. Because 5 times 5 is 25, and the square root of 25 is 5. Now what about that 2 though? Again, he's all by himself, so he stays under there. So the square root of 50 can be broken down into 5 square roots of 2. How about 300? Well, I don't know how you think of 300. Maybe you think of it as 3 times 100. And maybe you think of 100 as 10 times 10. And then you think of 10 as 2 times 5. So what are the prime factors of 300? Well, remember, it's a square root. We have 3 times 2 times 5 times 2 times 5. We have all that underneath the radical sign. That's how you get 300. Your job is to take as much out as you can. Well, what comes out? Anything you have 2 of. So what do I have 2 of? I have 2 2s. So out's going to come a 2. I have 2 5s. So out's going to come a 5. There's only 1 3. So what do I do with that 3? I leave it under there. Now, when you break this down into its prime factors, you are multiplying, right? So this is a multiplication situation. If you pull out a 2, and you could pull out a 2 because there were 2 of them, 2 times 2 is 4, and the square root of 4 is 2. When you pull that 2 out, and then you turn around and pull out that 5, because there's 2 of those 2, those numbers get multiplied. So your answer is 10 radical 3. Ay, ay, ay. I put variables in this one. What was I thinking? Move it up a little bit so I have a little more room here. Well, first of all, we're going to handle the 40 exactly like we've handled these. So what do you think of when you think of 40? I don't know, 4 times 10? And then what do you think of here? 2 times 2 and 2 times 5? So I have the square root of 2225. Now what am I allowed to take out? Anything that I have 2 of. Kids, you have to have 2 to take it out. So I've got 2 2s right there. So I'm going to take them out. Out comes a 2. Now what's left is 1 2 and 1 5. I don't have 2 of anything, so they have to stay under there. So there's going to be a 10 under there. Remember, this is times. So this made a 4. The square root of 4 was 2. This is a 2 times 5, so it stays in there. Now what about all these letters? Well, think about that for a second. X squared means XX, and Y cubed means YYY. Now what am I allowed to take out of the radical? Anything that I have 2 of. Well, look, I have 2 x's. So I'm going to take an x out. I have 2 y's. So I'm going to take a y out. Oh, what do I do with him? There's only 1 y left over. He stays in. And there is your answer. Just a couple more. Let's break down this one. How about 15, boys and girls? What do you think about 15? I don't think 15 breaks down. 15 makes 5 times 3, but in order to reduce the radical, in order to simplify the radical, what do I need to have? I have to have 2 of something, and I don't. So a 15 stays under there. Now tell me about x to the 5th. X to the 5th would be XX, XX, X. Now if I'm going to take something out of the radical, how many do I have to have? I have to have pairs, 2's. So there's a pair, so out comes an X. Here's a pair, out comes another X, so now I'm going to have X squared. There are 2 of them out there, X times X. And 1 lone X left inside. Remember, to take them out, you got to have 2. Y to the 10th. Oh gosh, I'm out of room. Are you starting to notice something now? You've got 10 Y's, kids. If you want to write out 10 Y's, you can. You're looking for groups of 2. How many groups of 2 are there? Why, there's 5. So out's going to come y to the 5th. Now some of you are thinking, Ms. Ford, I really don't want to write out 10 y's. That's a lot of writing. So I'm just going to think about this for a minute. I've got 10 y's. I'm looking for groups of 2. How many groups of 2 are there in 10? Do you see how it's a division problem? There are 5. Don't forget about this guy hanging on the end. What do I do with that little lone z? Well, there's only one of him. I need groups of 2, so he stays underneath. And there is the answer to the question. Now I want to do one more situation because I want you to understand that not every radical in the world is a square root. You could have a cube root, for example. Now, what does it mean to be a cube root? Well, you know some cube roots already. For example, you know that the cube root of 8 is 2. And why is the cube root of 8 2? Because 8, if you break it down, is 2 times 2 times 2. When we do cube roots, we look for groups of 3. So instead of finding pairs, which we do in square root problems, we have to look for groups of 3. Otherwise, everything stays the same. So I'm going to break down 54 exactly like I broke down my other numbers. So 54, I don't know, what is that? 6 times 9? And then 2 times 3 and 3 times 3. Now, what am I looking for here? I'm looking for groups of 3. I have a group of 3. So I can pull that number out, and the 2 has to stay inside. This is a cube root problem, so I am looking for groups of 3. Same thing with your letters. You have 5 X's. You are looking for groups of 3. There's a group of 3. There's only one group of 3. So out will come 1x. Anything left over has got to stay under the radical. So there's 2 extras that are still under the radical. How about y squared? That's y times y. Can I pull anything out? Please say no, because in a cube root problem, I need to have a group of 3. I only have 2, so they stay under the radical. And finally, z to the 8th. Oh golly, there's a lot of those. So again, like we were discussing a little bit ago, if you can think about this and logic it out without writing them all down, good for you. Just remember that it's a cube root problem, and we are looking for groups of 3. How many groups of 3 are there in 8? There are 2 groups of 3. So I'm going to pull 2 z's out, z squared. How many would be left over? 2. There is the answer to your problem. This is called simplifying radical expressions. So you will, or sometimes we call it reducing radical expressions. So if you want to do the practice problems in this section, feel free. Have fun.